Hello, welcome to another episode of Xa Talk Show. Today we are going to code Wolfram language, geometry, mathematics, and Wolfram language coding. Okay, and I'm also going to talk something about keyboards and JavaScript in the first 10 minutes. Let's have a drink. Oh, today is Happy Chinese Year. In America, you call it Lunar Year. Happy Lunar Year. Have a drink. So this is red wine and juice. Yeah, Happy Chinese New Year, Lunar Year. In America. Well, anyway, so let's start. So let's talk about keyboard. So this is ultimate hacking keyboard. Now you see the light are differently colored. What is the significance of the different colors? That the color are functional coloring, meaning that depending on what's the purpose of the key, they have a different color. For example, alphanumerics, modifier keys, some of them green I have here, and special function keys and key marker keys. I think I made it white, key marker or key remap. So anyway, functional coloring, which is an advancement of technology in the past few years. Ultimate hacking keyboard, this one. Okay, fantastic. And this one is Kinesis 360 wired, USB wired. Okay, it's also fantastic. And you see the background, that's red light. Red light is soothing. I recommend you get red bulbs. So red light is just fantastic. Red light, for some reason, human eyes have affinity with red lights. Okay, like you can see there's all kind of questionable theory about red light, how they cure your eyes. When you get old, your eyes get bad, and red light helps like reverse the process, something. Or the red light can, they cure your body or skin, something. But anyway, so that's a bit questionable, but in any case, what we know for sure is that red light is indeed soothing. And at night, if your wife is sleeping or your family, but you need to have light to work on things, red light, okay? Because at night, the red light is very soothing. It doesn't disturb you. For like when you wake up in the middle of the night, you turn on the light, all of a sudden it's too bright, But that doesn't happen with red light. Okay, so red light bulb is I recommend. So anyway, so ultimate hacking keyboard, Kinesis 360 wired version. Okay, that's my keyboard and my mouse, Logitech something. So let's go to my desktop and show you. Okay, we're gonna talk about mathematics. Okay, so can you see my desktop? Yes, this is tiling. Mathematics, geometry, the most beautiful thing, tiling. Okay, if you are watching this offline, you can play it at 1.5 speed, because usually I talk randomly and slowly and long. Usually my videos are 1 hour, so just skip around. So anyway, this topic is my last video. I did 1 hour, kind of give you a introduction, like so you can see all sort of tilings, what they are. But today we're gonna focus on this Wolfram language package. Okay, so this is what this package do: symmetry, tilings, wallpaper groups. So the purpose of the package is to generate any possible wallpaper patterns. Okay, any possible ones. And it's a deep topic. It's fairly deep topic. It's part of mathematics. So there are many ways to do it. So I'm gonna talk about it. So you can see this is Wolfram language code. Lots of mathematics. This is scientific programming, very different and unusual from industrial programming. For example, JavaScript, Python, PHP, Java, C, C++. You code every day, but you never think your code is never in this way. It's never like this. This is mathematical programming. So, but scientific programming or mathematical programming, except in the past 10 years, because the machine learning and big data and artificial intelligence, since last year, the large language models, AI chatbots. So you started to have a lot of code doing mathematics. For example, the ChatGPT, those chatbots, the code is all mathematics, linear algebra. Okay. So anyway, so here you see. So what's the example of mathematical programming languages? You can see that in Julia, in Wolfram language, and MATLAB, and R, statistics. There's a language called R. For example, you'll see a lot of scientific programming, entirely different nature than the industrial programming, web coding, web monkey. Okay. And if you are here, say hi. Okay. So today we're going to talk about tilings and patterns, and specifically what does this package do. Quite in depth, So and Wolfram language generated this PDF. This is the package I wrote 30 years ago. Yeah, exactly, 1998. Okay, so Wolfram language generate a PDF. Let me just go through. Let me show you. So this is my documentation from about 26 years ago, 1998, okay, in PDF. So you can see it documents what this package plain tiling do. And it's quite elaborate, quite details, the wallpaper groups. Okay, so anyway, let me just go through this, and I'm going to talk about keyboard for a bit, and some other things. Then we come back to this, okay? So this image is an illustration of a symmetry of a wallpaper pattern. So double lines means there's a mirror image. Triangle means there's a threefold rotation at that center, at that point. A hexagon means there's a sixfold rotation at that point. A diamond means there is a twofold rotation symmetry at that point. And the dashed lines means there is a glide reflection at that line. So what does glide reflection mean? For example, footprints. If you walk on a beach, you leave footprints, They are symmetric. Why are they symmetric? Because there's a middle line, you reflect it and you shift it, it becomes itself. Footprint patterns. So that's called, in mathematics, that's called glide reflection symmetry. So that's represented in this diagram by the dashed line. So double line is mirror symmetry, dashed line is glide reflection, and all the others rotation symmetry, different degrees. And there is also a translational symmetry, but I'll show you, okay? So anyway, so here's the different wallpaper patterns you can see, let's see. So you can see in this example, the L lines is a pattern, but this diamond, this triangle, this hexagon shapes, they indicate where are the symmetries. For example, whenever you see a hexagon here, that means at that point there is a sixfold rotation, meaning that if you rotate the whole thing 1/6 of a circle, it becomes itself, the wallpaper pattern. It may be a wallpaper, it may be a carpet, it may be a decoration on Islamic mosques. Usually Islamic mosques has lots of patterns. So anyways, here's a sixfold rotation. And this diamond, so you see this diamond, that means at that point there's a twofold rotational symmetry, meaning that if you rotate the whole thing around that point in 180 degrees, half of a circle, it becomes itself, okay? And the triangle, whenever you see a triangle on this pattern, that means there's a threefold rotation, same thing. You rotate it by 1/3 of a circle. So this diagram, is a indicator of the symmetry of the wallpaper pattern. And they are all together, the possible symmetries combination is 17 of them, only 17 mathematically. So anyway, that's the purpose of this package, to allow you to generate all possible symmetric wallpaper patterns, okay? So anyway, that's a diagram, and but that's not the only way to do it, okay? So here's a code, lots of code. Okay, so here is a diagram for the 17 possible wallpaper symmetries. So this one, the first one, it means this arrow we haven't talked about before. This arrow means there's a translational symmetry. That means if you move the whole thing by that arrow length, then it becomes itself. You move it again, it becomes itself. So for example, if you have a square grid, then you have this translational symmetry. And also you have another arrow there, meaning that you can move up. And this one, so you have two arrows, but you also have a reflectional symmetry. You see the double line in the middle? So that means you reflect the whole thing, it becomes itself, mirror. Okay, and the gray line, the gray area is called the fundamental region, meaning that whatever graphics in that region, once you have that, you can recreate the entire pattern, okay? So for example, this one, you have the gray, area. So whatever you draw there, you can repeat and recreate the entire pattern. Okay, so there are more. There are 17 wallpaper patterns, symmetry, ways of symmetry. I talked about this in my last video about 4 days ago, so you can watch that. Okay, so there are several. Okay, so let's go on, and okay, anyway, this is a PDF documentation, and you can download it. Let me post the link. If you are here, say hi, okay? Hello, Ceros. Hello, Chris. Hello, Joman Molina. Okay, let me post my page so you can kind of marketing, okay? Cut it and paste the link, and you can get the PDF, the PDF file. It's actually very good. The Wolfram language created this PDF. Okay, let's scroll down. So let me just finish showing you some of it. So here's a grid of different color patterns. This pattern of dots, I call it a star pattern, okay? A star pattern. And here is another, wallpaper pattern, very interesting. So you can start to see knots and weaves. This pattern is very common. In fact, it's in your textile. If you magnify it in some textile, your clothing. And you can also see some chairs made out of bamboo, weaved in that fashion in Chinaman hats, for example, the triangular hats, walking in the rice field. So some of the interesting patterns. And mathematically, it's very interesting because you have to analyze what are the possible weaving patterns, But anyway, for our purpose, our package is designed just to generate these images. So this is an example how you can create this image. Okay, so some more. Okay, snowflake patterns, some kind of snowflake and honeycomb patterns. Okay, and this is error network, very interesting. Okay, and okay, there's quite a few. So here's a star motif. So for example, this function polygon motif generates this pattern. Then you can map this pattern to for example, to each one of these points on the grid. Then you get a beautiful symmetric pattern. Okay, that's some of the ways to generate decorative patterns. Okay, so this is long. I want to talk about keyboard a little bit first, as I promised. So you can see some Islamic style patterns, and then we come back to this, and I'm gonna show you some code, real time, running them. Wolfram Mathematica, okay? Wolfram Mathematica is amazing. It's truly amazing. You know, I was just reading the Stephen Wolfram's Mathematica, Stephen Wolfram's Wolfram language version 14. He has a blog. Just search for it. Version 14. What's new? So it's tremendous. Anyway, that's another topic. So let's go back to. Let's tell you. Am I going good? Am I doing good? Am I talking? Is it interesting? So let's go back to keyboard a little bit. So there's some keyboard news. So we talked about, let's see, can you see it? Yeah. So keyboard, so happy hacking keyboard. Here's a beautiful photo. So you can see functional coloring. Great photo, okay? You know, check out my website. XR keyboard blog, so you can read about all the details. Now, here's another interesting thing. This svalboard, which I'm going to get one, and I'll do a review for you guys. Thanks to this guy, very nice. You know, so you know he created this datahand svalb keyboard. Let me show you what that is. I talked about that before. So anyway, it's a kind of funky keyboard device. So supposedly this device allows you to type in a different way and pretty efficient, and more efficient than a normal keyboard. That's the premise. That's why there's this such keyboard, datahand, an alternative input system. You can buy it, and now there's a discount. Okay, there's a discount. So you go to their website. There's a discount. Okay, I haven't used it, so I don't know how it's. I never used the datahand before, but it would be interesting, and I'm gonna review it for you. But if you might already know about it, so you know there's a discount. If you want it, you can get it. And datahand. Okay, so XR battle stations. So I took a few new photo again. There's Kinesis 360 is still my favorite. Okay, I don't use it because I have so many, so I use that on my bed for my bedside. And then Kinesis 360 glove. This is glove 80. Kinesis 360. Okay, and then you have the Happy Hacking version 2 and version 1. Fantastic. Okay, now all these three I highly recommend. You should, when you buy them, get the linear light switch, like 35 grams of force. Now they have so many names for this switch today. Some call it pink, some call it pro red, some different names. But anyway, make sure you want linear switch and you want it light, like 35 grams activation force. Okay, that's what I recommend, and that's what I have on the Ultimate Hacking keyboard, on Kinesis 360, and on my Glove 80 linear light switches, 35 grams activation force. Okay, make sure you get that. If you have your own opinion, then go with your own opinion. But if you don't know about anything, I recommend the light ones. Okay, especially if you type a lot. Get used to the light ones. You may not like it in the beginning, but just get used to it. Okay, so and here's my other keyboards I have. And Kinesis, this is Kinesis 2. Okay, anyway, these are old, so I'm just gonna and let me show you the old one. This is 2015, my battle station in 2015. Okay, that's about that. And let me show you this one. This new discovery. I think this is a great keyboard. Okay, this is epomaker from China. So they made a new Alice layout keyboard. Now this kind of layout, you can see, is kind of funky. It's not conventional. Conventional is like a laptop, flat, rectangular. So this is not conventional, nor is it like two sections of a linear grid. So it's a bit funky. So that's why they call it Alice keyboard, in reference to Alice in Wonderland. Alice. So, but anyway, I think this is a good one. Okay, I don't have it, so I can't say for sure. That's about keyboard news. And here is my best ergonomic keyboard, XR pick. So this is my opinion, which one is the best. And another one I haven't mentioned is this Expose. I really like it. Actually, okay, not this one. You want to get the new one. Yeah, you want to get this one, the newer version. Expose Night keyboard. I highly recommend this one too. In fact, this one is cheapest among them all. So if you don't have much money, you want your first ergonomic keyboard, get this one. Okay. Okay, so I need to update the link here. So, and yeah, okay, there's Ultimate Hacking Keyboard. Okay, so that's XR's best ergonomic keyboards. XR pick, my pick. Okay, that's about keyboards. Okay, that's about keyboard. Okay, let's go back to, if you are here, say hi. Okay, hello 6. Now let's show you a JavaScript. Now I just did it today. Someone is asking about dark background. So this page shows you how do you make a JavaScript button that changes to dark theme and change to light theme. See? So this is all you need. You just need this code in the HTML, and you just need this code in the JavaScript. Okay, that's all you need. So this is part of my JavaScript tutorial. JavaScript in depth, the best in depth on technicality of JavaScript in English language on earth. There's no other in English that's better. Okay, including all printed books. I talked about this in one of my videos like 2 months ago or so, about the detail. Okay, part of JavaScript in depth. Now let's get back to the tilings. Okay, yeah. So let's see. Did we talk about all the things I want to talk about? Yeah. So I showed you my tiling page. Okay, let's start to talk about tilings. 罗健 ，Hello 罗健，罗健你好，罗健 ，Are you? Yeah, good. So okay, Happy New Year, 新年快乐。So let's talk about. So yeah, let's start to talk about mathematics. So okay, am I ready? Yeah. Let's see. Concurrent viewers. What? Good. Okay, so yeah, let's talk about plain tiling. Plain tiling. So my packages, here is a code actually. So here is a code. You can see. Let me show you. Okay, so lattice test. We want to open that, and plain tiling documentation. Let's open that. I'm working on to publish this. So I wrote this in the beginning of 1996. Very technical, very technical, and very powerful package that allows you to draw any possible. That means that's the purpose of this package, to draw creatively any possible wallpaper patterns. Okay. So you can magnify. So in Wolfram language, you can magnify these graphics to any size, and it's very sharp, and you can export it. You can convert it. You can save graphics. Save graphics. It supports like PDF, HTML, EPS. That's PostScript, GIF, JPEG, PNG, PXR. I don't know what that format is. SVG and TIFF. In fact, you can export it to almost to basically any possible image format that exists, or even CAD formats like 3D formats, any possible Wolfram language. That's one of the great things about Wolfram language. It's just amazing. Any possible, graphics format, codec, graphics format, video format, or CAD three-dimensional format for animation, for computer engineering, for car manufacture, or whatever, for space shuttle or whatever, the AutoCAD and whatever. Anyway, so here is the package. For example, let's delete that graphics. Let me show you. I can run it. Okay, so click on that, run it. Okay, it's loaded. Now let's say this page. Okay, shift enter to run it, so it generates the graph. Okay, so for example this one, run it. Okay, I can delete that and run it again. Okay, so you can see all of these are generated. So let me show you. Run this. Okay, let's change this. Let's make it a colorful. Okay, so instead of that, let's change. So what's going on with this one is that you map a bunch of pentagram stars into I believe, triangular points. Okay, so you map this star motif. Let me show you. Okay, so star motif. Not here. Don't. So let me show you some of the things. Copy this, paste it, run it. Okay, so it actually shows these star graphics. You can type question mark star motif, and it will show you the documentation. Star motif and R1 R2 returns a polygon that represents a star-shaped polygon of n-fold symmetry and radii R1 R2. Okay, so let's try that. Okay, so star motif. What are the other things? It's star motif. Oh, a bunch of then you can say star motif R1 theta, R2 theta uses polar coordinates as vertex. Okay, then you have some variations. You can also scale it, rotate it, and translate it. Okay, but let's not do that. Let's just say 5.3. Let's see what we get. So n, then what? Does that work? No. So let's just say n. Oh, okay, so you need 2 arguments. Let's say 2 and 3. Let's see what we get. Oh, okay, so we got that. So this is 5-fold symmetry. Let's say 2 and 4. Okay, and we can, if you want to show a large graphics, you can do show graphics. Okay, and there it is. So now let's change it to 6. So you got 6-pointed star. So let's make one of them, let's say 242. Let's see what happens. Oh, you see, I wrote this 25 years ago. Very general, okay? You see, this has to do with the design of the function. So when you write this function, oh God, now you got ninja dots. So when you design this function, for example, star motif, the goal is that you want this function to be able to create all possible star patterns. Now, what does that mean? Well, you just have to think about it. Is it, how do you define all possible star? Can it be convex? Can it be convex? I don't think my code can actually generate convex. But anyway, give you a lot of variation. Let's say, oh, very interesting. So you see, then you map a star into a wallpaper plot. Oh, let's do that. Okay, so let's do that, and instead of this star motif, let's use this thing. Okay, and let's just show it. Oh, okay, it's like this is too big because they are all jumbled, congested together. So let's shrink the whole thing by times 0.2. Let's see what happens. Okay, still too big. So let's shrink the whole thing by 0.05. See what happens. Oh, okay. Now that's not too good looking, so let's increase it a little bit. Now it's starting to get interesting. So now let's say 6 on each side, on each vector basis. So you started to have these interesting graphics. Okay. Now it looks like, I don't like the look of this. Let's say 3. Okay, so you can see interesting patterns. And can you rotate it? Yeah. Scale and rotate. Let's rotate by 30 degrees, okay? By 60 degrees, pi over 2. Okay, did that work? Pi over 3, I typed it wrong. Okay, that seems no effect. Let's see. So now let's look at the documentation again. Star motif. Now let me show you the code. Okay, so here is the code. Here is a code shown in Emacs. So it's plain text. Let's search for star motif. There it is. So here is the beginning of the package. Here's the inline documentation. That's what you see here. And here is the various definitions of the function star motif. So this is defining one function. The function name is star motif. So you might be wondering, how come you have so many definitions for it? You see, this is how you do, in the OOP jargon, it's called polymorphism. Okay, so what does that mean is that if the function is given 2 arguments, the first one is an integer, the second one is a vector, then you do this. Okay, now if it's given 3 arguments, the first one is integer, the second one is a vector, the third one is a number scale, then you do this. You see, so this is how you can create what so-called polymorphism in programming. So far so good. Any questions? Joman Molina says, have you considered posting on the Wolfram community? Yes. Yeah. The thing is, I just haven't, I'm busy with my own stuff, so I haven't really joined the Wolfram community for discussion. Let me tell you about that a little bit. Are you a Wolfram programmer? Maybe I asked you before. Are you a Wolfram programmer? So I've been with Wolfram. Okay, so Wolfram community. So let me tell you about that. So Wolfram community is a forum. Okay, hold on a second. Let me talk about that and this one. So Wolfram community is a forum created by Wolfram Research, the company that makes Mathematica. So they created their own forum, so you can ask questions, you can talk to other people who program in Wolfram language. And we have several mathematicians here. Typically these are these people, look, each one, these are not the Zoomer facts. They are not the Melangen facts. Okay, these are serious people, scientists, engineers, computer scientists, computer program. They are not the online chat random and gamers, that kind of shit. You can see each one of them has a photo of their face, and usually they are not young people, they are professionals. So okay, yeah, so this is Wolfram community. That's basically a forum, online forum, that lets you talk about Wolfram language coding and whatever related stuff. Okay, aftermath of the solar eclipse on other planets. How do you display bar chart labels below x-axis? All sort of questions and stuff. And I know some mathematicians are here. So there's a physicist, Wolfram University. There's a physics, geometry. That's my interest. Numerical computation. There is curated data. That's my least interesting things. Curated data. That's kind of like the online database. For example, get all the information about DNA. Get all the cities in the world, the names of all the cities and their population of the world. Get all the that's this curated data is about. So you can do that in Wolfram language. You can get all the countries in the world, things like that. You return. Anyway, that's not my thing. I'm mostly interested in mathematics, geometry, and computation, and the basic, mostly pure stuff. But anyway, Wolfram community is a online forum created by Wolfram. Now, before that, there's also Stack Overflow, Stack Exchange on Mathematica and Wolfram language. So there's that also. I believe this was earlier. Then Wolfram created Wolfram community. So anyway, I haven't used them. Well, because I was just busy, I've got enough things to do, and I know I do have some questions, but rarely. Usually when I have a question, I know usually I know the answer because I've been coding Wolfram language for 30 years. So anyway, and before that, before these internet things, then you have the math groups. Okay, math group is a mailing list, which so it's another Wolfram forum, online forum, but that's before the web browsers, before internet. So it's a news group. So it's called Math Group. Anyway, it's a Newsnet. Okay, it's Usernet. Is back in the 1990s. So over about 7 years, I've been on that forum. In the 1990s. Anyway, so that's about that. Oh, you use Wolfram language. Okay. Welcome to the team. So yeah. So one thing about Wolfram language is that it's not it's not purely for professional programmers. In most other languages, especially C, C++, Java, it's only for professional programmers. It's not for hobbyist programmers. It's not for amateur programmers. Even if you are a greatest mathematician, you have the biggest brain, but if you are not a professional, you can't use their language because they talk about little things of no interest to you. Most programming languages are like that, and Python is a bit better. But anyway, so Wolfram language is kind of special in the sense that it's easy. It's very technical, detailed, covering the most esoteric mathematics. However, it's very easy to understand, even if you don't know the math. They don't talk about things you don't need to know. You just need to know, how do I draw this? Write this, you draw that. Okay, you don't need to know memory, whatever jargon, computer programming jargons. You don't need to know. That's one thing great about Wolfram language. It allows any technical person, as long as you know what's a computer, you can, if you work with computer, you can use it easily for anyone to do a lot of very extremely complicated programming. Okay, I digressed a lot. So let's so Wolfram community. Are you in Wolfram community? Joman Molina. So I was planning to do so because sometimes I do have questions. Oh, so okay, great. So these are Michael Trott. Some of the people I recognize. Michael Trott is one of the greatest expert at Wolfram research. He's Michael Trott. His background is physics. He's a physicist, and he's I would say top 10, the world's top 10 Wolfram language programmer. Michael Trott. Okay. He worked at Wolfram, of course. Now, some of the others, do I know them? Brian Beckman. I guess I can, I'll see some of the people I realize, especially the older ones, because, anyway, so yeah, Wolfram, yeah, so I'm going to join, but I haven't so far found. Yeah, I need to join though. I'm gonna join it soon because I do have some questions. Okay, so let's go back to where are we? So plane tiling curves. Okay. Okay, nested. So yeah, so we are showing. What are we showing? We are showing the star motif. So let's get back to the star motif and let's see exactly what other. Okay, so you can the first argument is the symmetry, how many fold symmetry. The second argument is a list of radius. Okay, so a list of radius, let's say 2, 4, then you got sharp star. If it's 240, then you got very sharp star. Let's see what happens to that if you try that. Wow, interesting. Let's add a color. Okay, so I want the color somewhere. Yeah, so let's okay, you want color, let's just do it what are these arguments? I think I got it wrong. 1 pi 3. Wait, I got it wrong. Yeah, so no wonder. 1 pi over 3. Let's rotate it. Oh, okay, let's say 1 pi over 4. Let's rotate each of these star by pi over 4, which is 90 degrees, which is 45 degrees. Let's see. Oh, okay, so wait, that's scale. That is that. Let's go back to see the documentation. So scale alpha. So scale. So after the list of radius, then you can say a scale. Then alpha is the angle for rotation. Then a vector for translation. Okay. So you got a, let's say, so rotational symmetry of 3, then 2 radius, let's say 2 and 6, 2 and 7, okay. Then scale, let's leave it 1. Then rotation, let's say 0. Okay, let's see what happens. Okay, so let's change this to 1, 7. Okay, scale 0.5. Okay, let's shrink it. Okay, so let's say 0.1 and 0.7, then scale 1. Okay, now that's better. Now let's rotate it. I wanted to do rotate by, let's say, pi over 3. That's 1/6. Okay, let's say pi over 4. I want to see some effect. Oh, that's interesting. But why does that do that? That seems kind of odd. So anyway, that's some of the interesting, this is one of the way to generate a wallpaper pattern is by mapping a motif. Let's see, let's go. Okay, okay, so anyway, you map a motif to each one of these points. Okay, now there are other ways. For example, the other way is, for example, this way. So let me show you. So we can run this, delete, okay, delete that, run it. Each time it runs, it'll generate a new graphics. You see, run it. This takes some time, generate a random different graphics. So you can see how is this one generated. You see, this is a random wallpaper plot. Okay, so this is generated by where did the other here. So this is generated by you create an image in this little triangle. This is called fundamental region. Okay, so once you have this image, it's called motif. Then you just use the symmetry to repeat it all over. So, so for example, you have this mirror line, so you can flip it over, then that'll cover this area. Then you have this triangle, means threefold rotation. So you can rotate this thing, 1/3 of a circle. Then you basically fill the whole thing. So each one of these is a symmetry. So then you get the whole parallelogram. Then you can just translate, then repeat the whole, fill the plane, and the result looks like that. Okay, let's magnify. Okay, so that's the result. This is, this is what you see in kaleidoscope. Good morning, Johan. Denise, hi Xa, do you read comments? Yes, of course. What are you talking about? Okay, we talked about that. Let's see. So what else I want to show you? Some interesting things about. I wanted to code. So one way to draw a wallpaper is based on symmetry, wallpaper groups. Okay, that's what this one is about. This is one of the way to generate. You see, you can also use this way to generate these graphics we just showed. But you see, the interesting thing is that it's a different way. It's entirely different. In this way, we simply map a star-like graphics to all the points on the grid. But in this way, you start with the fundamental region of the symmetry. Then you create this. Of course, we can use this way to create that, or we can use this way to create that. They are interchangeable. But however, the method to draw them is very different. So it's very hard to go from one to the other. For example, if you want to draw these graphics by the way of symmetry, then you have to find out the coordinate. You have to find out the little coordinate of this little region. It's not so easy. So anyway, that's some of the methods to draw symmetric patterns. Okay, and here is a rectangular. Here's an example of a different symmetry. Can you make the colors more complex? Oh, Reaper. Hi, Reaper. Denise says, did you use 3JS or Unity 3D for these jobs like geometry? No, I use Wolfram language Mathematica. Okay, the 3JS is crap. 3JS is tremendous crap. I have an article on that. Okay, 3JS is an incomprehensible thing. Let's see if I have a documentation of it. I have a blog about it. It's called 3D.js, right? What was it called? .3D.js. Oh, D3.js. That's right. D3.js. I have an article on that. In fact, I talked about it a little bit. There it is. D3.js visualization, a quasi-science. Okay, I think this guy, the guy who created D3.js, he is one of the top visualization expert, I would say. Okay, he's one of the top visualization expert, in particular using JavaScript to do it. But however, so he wrote D3.js. However, his creation is kind of crackpotish to me. Okay, you can go to his web. This year's this guy, Mike Bostock. Okay, you can go to his website. In fact, he's a very beautiful website, tremendously, and the images you create with D3.js is very complex. Okay, let me show you where. Wait, is this the article? Okay, let's go to it. So here's his website, but he's got to me, he's kind of a questionable crackpot kind of thing, his creation. Okay, D3.js is very difficult to use. However, his code, his stuff is very good. Let me turn on JavaScript. For example, I'm very impressed by, for example, this is website. So in this article, he's talking about algorithms, visualizing algorithms. A very good article, okay? But his D3.js has got problems, okay? Anyway, so you can see this is D3.js, okay? And what's this one? Click. This is random, okay? What does this one? Oh, okay, so it allows you some kind of rasterize, or what about this one? Okay, click. Let's see. Click. Some of them are great. Click, so you can redraw it from any point you click. Poisson disk sampling. So he's talking about. And what is this one? So this is something. But anyway, there's a graph. So here is a visualization of sorting. Okay, you can go to his website. A visualization of what? Bubble sort or something. Shuffling. Okay, so you can reshuffle. Okay, so and here is let me show you. There's one interesting. Okay, I want to show you. Beautiful, and also this is a beautiful graphics. Okay, beautiful graphics, and it's done in JavaScript. Not easy to do. Very difficult to do. Okay, and he did it with D3.js. Very beautiful. And then let's see. So here's some kind of sorting visualization of merge sort. Okay, another one. Okay, here is interesting. Oh yeah, I was amazed by this one. Beautiful. This is like creating a maze. Okay, there's more, and watch this one. This is a different visualization of the same maze. Okay, you can, very good, very beautiful, and very difficult to do. And you got it, and that's not all. Okay, so another one. Yeah, okay, so another one, this one is kind of doing how do you call it, the backtrack algorithm, something like that. What is this one doing? Trying to solve it, something. So anyway, and I'm most spectacularly impressed by one of them, not this one. Okay, I'll show you. Not this one. Yeah, not interesting. Okay, not this one. Not interesting. By this one. I'm most impressed by this one. Look. So you start with a kind of maze, and this maze is actually made out of one single line, and you redraw it in kind of three-dimensional way into a tree. You see, this one is I'm very impressed by this one. Okay. This is D3.js. Who wrote this? I think he did, right? I think he did. Yeah, so anyway, D3.js is his creation, okay? But D3.js, I think I find it problematic. I find it kind of like a crackpot. Okay, he's trying to create a new kind of framework for creating visualizations. That's what he's trying to do. So here's my article. The title is D3.js visualization, a quasi-science. That is my criticism of his article. In his article, for example, introducing D3 scale. So what does that mean, introducing D3 scale? Now, when we create graphics, we have constantly we have scaling issues, like the label you need to scale in a certain way, or if you have a bar chart, you have to scale the bars. Sometimes they are too wide, sometimes they are too narrow, or the height, sometimes you want to rescale all the height to logarithmic scale or something other. Okay, so you have the scaling issue. So he's talking about scaling issue. How do you do it in D3.js? But now look, introducing D3 scale. So he's creating a new vision, new way. So in his, I read it. It's like usually it's incomprehensible. You have to spend a lot of time. So he's creating a new way. So you don't just view it as a scale. You view it in some other way, this way. Therefore, the whole thing becomes easier. I find it problematic. Okay. And I criticize in each detail. So anyway, that's what I have to say about that. So it's been an hour already. Okay, so I think I talked for an hour. Let's go back to my talk show page. Let's see if there's something I want to really say. Map a motif to a grid, or triangular grid, or star grid. Okay, we already did that. Yeah, we mapped a motif to a grid, but let's try another thing. Okay, let's just try some random. Okay, let's say instead of wallpaper 15, here we have a particular symmetry, ID 15. Now let's try ID 14 with the same motif. You get that? Let's try ID 13. Okay. Now let's try ID 12. Another different symmetry. Okay. So now you get rectangular symmetry. Now let's try ID 11. Let's see what we got. Oh. So anyway, that's why it's interesting. It allows you to create any possible wallpaper patterns, decorative patterns. So why is it useful? There are many purposes. For example, if you are a mathematician, you are studying symmetry, you write papers, there's quite a lot unsolved issues, especially on tilings. You can go to Wikipedia, tilings, then you'll see a lot unsolved. It's very deep mathematical problems. So if you are a professor, you are a researcher, you need to, when you research the mathematics, you also need to show illustration. So this package is very useful to show the illustration, what kind of theory you want to say. Okay, that's one application of this package. Another thing is, let's say you are a interior designer, or you are a literal wallpaper designer. You create these kind of patterns people want to buy, to decorate their house. Or if you are building a church or a mosque, or or your garden, your backyard garden, and you need schematics, you need so you can use this package to help you draw it. So that's interesting about these things. And there's other things. For example, this one is interesting because this one, before we showed different methods to generate a tile. One is by using the symmetry information. For example, this is a symmetric fundamental region. We just use symmetry to generate the whole plane. Or Another way, which is the most typical, simpler way, is you simply map a motif to each grid points. Okay, so then we have these various examples, right? Then another way to generate a pattern is by this. Let me show you this way. So you begin with a triangular grid, okay? Then consider, so you begin with lots of triangles on a grid. Then consider each edge of a triangle. You transform that edge into kind of a kink. Then you get this, you see? So this is a transformation of lines. So you see, you begin with this line 0, 0, 1, 0, 1, negative 1. That's 3 coordinate. Then you transform that line into this. So basically you introduce a kink. So then you apply that to all line segments. That's what you get. Very interesting. So this is another different way to generate a regular symmetric pattern. Okay. Okay, that's and here is a similar. This is an example of that by transforming line transformation. You can see we have nested line transformation. This is a famous curve called Koch snowflake. Okay. If you don't know that already, so let me show you Wikipedia. This is one of the classic fractal. Okay, this curve is called Koch snowflake. So you begin with a line segment, then you break it into before you have a line, then you break it into that. Then you do it again for each line segment. So this is how you get that. And we can do that on a tiling. So for example, let's get one more recursion out of this. So right now it's 2, let's say 3. Okay, so you can see they become more fractaled. You see? Amazing. That's very interesting. So it's a new way to generate, it's a different way to generate tiling. And others, okay? There's many other interesting things. But I think that's it for today. And here is an example. You just map a polygon, a huge circular thing to the grid, and you get that, okay? I think, and here's a beautiful one. Okay, I think that's it for today. Thanks for explanation, and I'm sorry for interruption. I was wondering your opinion. Can you make colors more complex? Reaper's question. Yeah, of course you can, but what do you mean color more complex? Now Unity 3D I haven't tried, but I think that would be fun to do it. Okay, that's it for today. Thank you guys. DFS. Now Valley says DFS. Now I believe that DFS is a 3-dimensional format, right? Let's say Mathematica DFS. What is DFS? Depth first scan. Okay, I don't know what. Okay, that's it for it. That's it for today. Thank you guys for watching. Bye, guys. We talked for 1 hour. Did we cover everything I wanted to say? More or less, yes. Transform lines, yes. Transform lines or pattern recursively, yes. Show an example, mapping circle to rectangular grid or to triangular grid or to star grid. Now today we mostly, we have done mapping it to a triangular grid and the rectangular grid. Okay, that's it. Thank you guys. Now, so if you enjoy my stuff, so I have a few things to sell, which is a way for you to thank me, to donate, to give me money. So one of them is, so you go to xali.info, it's Xali web. So one of the way is you go to xali.info, then you go to Emacs. So I have a lot of tutorials on technical information, on programming, on mathematics. So you can go to Emacs. So here is my tutorial for Emacs and Emacs Lisp. And I also did a video, I did over 100 videos on. For example, this video is very good. Xal Talk Show 2000 September 7th, Emacs Lisp for Beginner, one of my most popular video. 10,000 views, 20,000 views, something like that. So you pay me to get my Emacs Lisp tutorial, so you can use it on your local machine without internet connection. Okay, that's one way you can donate to me. Just go to it. Or you can just Amazon me money, Amazon gift card or PayPal. So go to xali.info. Let's go back. Xal code, and all the way down, you can Patreon me, you can Amazon gift card me, or you can PayPal me. Okay, that would be nice. Or you can also buy my JavaScript tutorial, JavaScript in depth. The tutorial link is here, JavaScript in depth, and go down topics and buy Xal JavaScript in depth. There it is. Okay, thank you guys. Bye.